Hi, it's Gadget UK here again. This time we're looking at a power supply for a Dell server. So you can see the model number on there. It's an L305P-01. Yeah, so this belongs in one of the servers for the company I work for, actually. Now, my boss Simon, he actually had a spare, was thinking ahead. I think he actually had a complete spare machine, actually, so for redundancy protection. Should the controller fail, or the motherboard, or the power supply. So yeah, that was good forethought on his part there. So from what I understand, this was working fine. It's been in use, constant use. I'm talking about like never powered down really, other than just for the occasional reboot, for 10 years, something like that, I think. Maybe a bit less, maybe a bit more. And then he's done an office move, so the machine's moved from one room to another, and obviously it was powered off for probably a few hours, maybe even overnight, and then when he's come to power it back on, it's just dead, completely dead. So I'm thinking it could be like a capacitor on the startup side, the power supply. It could be capacitors need replacing, throughout this. It could also be just a dry solder joint, because I do know from my experience in the past, some of these Dell power supplies, when you use them for extended periods of time, you can get dry solder joints developed on them. On my own home machine, actually, I saw that same thing. I think there's an earlier video. I'll perhaps put a link down to it, down below to it. It was the same thing with that bad solder point from continuous use and very few, or power cycles. Power cycles was the issue, I think, in my case. But you get the same thing for extended periods of uptime as well. So I'll get all the screws from around the edges and stuff that hold the case together here. So it's important to point out, if you're not used to working on high voltage things, like power supplies and monitors and things like that, don't go near a power supply like this, because just by virtue of removing the screws here and going inside there, we're going to expose ourselves to high voltages. So even though this isn't plugged in, capacitors in there will hold very high charges for a period of time. If we're lucky, there might be some bleed resistors or something over them, or if it's been powered off for a period of time, the voltage will gradually diminish in those capacitors. But you've been warned, you could easily kill yourself working on something like this. The other thing as well, don't test it when it's exposed, like when you put the board out and stuff. And you need to be very mindful of how you're taking it apart and how you put it back together, because there'll be bits of isolation and stuff in various places, and if you miss one of those, you could make the whole chassis here live, although this should be earthed. In theory it should just blow a fuse if that happened, but you could kill yourself. So do not work on power supplies if you don't know what you're doing, and don't necessarily follow what you see me do in this video. I may make the odd mistake, so yeah, you've been warned. This is a vloggy sort of video, really. You should just take it as entertainment value and not really use this as any kind of guide or tutorial. So I've got all the screws out, but it looks like this is kind of cable tied on here. Look, it's like a final safety thing, so we'll have to put a new cable tie on there like that later. Let's just pull that off. So it's just kind of holding it to the cam there, and I think if we're careful, yeah, you can see these sort of things are really difficult to work on, because we've got what looks like a transformer mounted up there, and obviously it's attached to the board there. It's a bit dirty and stuff in there. I can see some swollen capacitors down there already. Look, can you see that? Look at those blue caps there. Yeah, it's going to be a capacitor issue, this, I think. So as you can see, I freed up that transformer there. Let's just carefully just sit that down there for the moment. So I need to vacuum this out next, but yeah, so hopefully you should be able to see a bit more clearly now. Can you see the top of this cap here is a little bit domed? This one, this one, this one. That one looks alright, but I'd swap it anyway. This one, that one looks alright, but again I would swap it anyway. Same with the smaller one there, that one's alright. And some of these smaller ones here look okay, but again I think I would swap them. That one there, that's domed as well. So there's the main caps there that are going to be holding the high DC voltage. It could be 337-ish volts here in the UK. Obviously it's going to be less of a DC level there in other regions where you're using 110 or 120 volts as your input supply there. And I guess that's where this transformer comes in. Maybe that they had a different one per region, because it looks like the mains come straight in through there and back out or something. It's really weird. I'm only seeing, oh yeah, there's four wires on there. So I need to cut this clip here as well. Careful not to snip the wires. Now, one of the complications you can have working on a power supply like this, and they're nearly always the same, everything's soldered straight on. So like the fan, you can see the black and red wire here, it just comes, you know, down under here, soldered straight to the board. The connections for the transformer are soldered straight onto the board. There is no connection there. You can just connect, you know, to make it easy to work on. The same with all these wires and stuff coming in here and the ground and everything. Everything is soldered straight to the board. It's kind of not designed to be easily serviced, but you know you can. It just takes a bit of effort. So I'll have to unscrew the earth thing there. I'm probably going to need to unscrew these things here. I probably need to unscrew the fan as well, and of course unscrew the screws in the corners of the board here, and then be very careful when I'm taking it all out, making sure not to electrocute myself on any charge that's still on the board here. So this was wedged in there and had some of that Celastic stuff, you know, it's kind of like you know, hot glue effectively, and then just pull it out. It's got really stiff wires in order that I can get access to the screw. You might just be able to see hopefully down there. So after disconnecting absolutely everything there, we are in there. So we can see this is the caps here that hold the high voltage, so it's a bit dirty around there, and again it's dirty up this side of the board, and some of the solder points here look crusty as anything. It looks like there's even been a bit of arc in there on that one. So all of these things here are going to need reflowing and cleaning up. But the main thing to do now is clean the board up, you know, vacuum off all the dust, vacuum out the can there, reflow some of these things, remove the caps we know are faulty, remove the remaining caps and ESR test them. But before we do that, we want to just measure the voltage on these caps here and see if they need discharging. So you can see the meter here on volts DC. I'm very careful not to touch the actual connections with my fingers and just measure. So yeah, that's discharged, and that's the other cap that goes kind of diagonally there. Yeah, so that has discharged. We're seeing no voltage there. If we did see some voltage there, and we could do this anyway, just as a precaution, plastic handle, you know, so it's isolated handle, thing like this, and just carefully touch the points together like that. It goes without showing that none of this should be connected up to the mains while you're doing it either. Might not be obvious, but I've got to point it out. So I cleaned the fan out here with cotton buds. You can see the cotton bud was pretty dirty. You could replace a fan like this whilst you're here. So before I even replace the caps, I'm just going to have a bit of a clean with a cotton bud here. Actually, I've vacuumed the board, but it's quite difficult to get the vacuum right in there. That's the problem, which is why I want to just have a go with the cotton bud here. So I won't bore you with all the removal here, but you can see that's what I think is the pin for the cap, and I'm wobbling the cap. Can you see that on the other side? And the pin is moving, so I know it's definitely these 2 points here. So I'll add a little bit of fresh solder containing lead, you know, it's leaded solder there, and flux. So after having removed most of the solder, just heated each point, pulled it through, and then unblocked the holes. You can just about see the cap position down there. I'm just going to now clean with cotton bud and some IPA, just in case there's any kind of electrolyte there, but you tend to find it dries up in these and then they don't. It's rarer for it to just leak and spew its guts on the board. But if that was the case, you would need to get lots of IPA on here and brush it and brush it and brush it. But it's very difficult because you can't get clearance around anything, look. So it's often why power supplies like this will just get binned. So when you've got a cap that's clearly domed like this, there's actually no mileage in measuring it at all. Just swap it. But out of interest, we'll measure it anyway and just see if it's reporting anything. It probably will do. Yeah, you go, 4.7 microfarads, ESR 20.5 ohms, can you see that? So that has turned into resistor. Its capacitance rating's dropped because obviously it's the electrolyte's gone in there, it's dried out, and you can see that one's supposed to be 220 microfarad, 35 volts. So yeah, I won't be measuring the, I might just do them at the end, the domed ones. And obviously I'll be taking the ones that aren't domed off and checking those as well. So sorry if you can't really see very well here. This is a tip from Volta. You get a cotton bud with IPA and then push into, squeeze the cotton bud against it and push into the Celastic there, or hot glue. And as you can see, it's separated it. Before doing that, it was well and truly stuck on there. So I've ordered some new capacitors here. I've had to order 4 of these, multiple packs, but and bear in mind we haven't replaced everything here, so I might need to replace some of the others on the board anyway, so it was a good idea to just order a couple more of each. This one I thought was 63 volts, but I'm not sure you can see that. The stuff there was covering the dot, so I thought that was 63 volts, but actually it's not, 6.3 volts. So I'll wait for those ones to come. But these two I do have spares for. I've got a 3300 there. I'm not sure about the brand, but I've used these on my own power supplies here in the past and they've been okay. And 2200, so I can fit those two. Just need to wait for the other four to arrive. So I'm not sure if you can see this, there's like a black mark on the circle that indicates the negative. So the negative of this cap here is this pin, you know, it's nearest there. And the negative of this cap here, again, is that pin there. So the 3300 goes over here, I think. The other spare that I do have now is the middle one here. I can't wait to be done with this power supply. I tell you what, it's super fiddly to work on. I mean, you could desolder all the things that are hanging on here, but if you're careful, you don't keep flipping it in different orientations, try and get all the caps off as quickly as you can without having to move the board. In theory, it shouldn't be too hard. So I can reflow these in a second. I just want to just get it into position there. Let's just do the other solder point now. Got to be very careful because there are, can you see some surface mount components just near those cap legs there? It's very easy to bridge something here. I really need to get the board flatter like that. I'll move the solder out of the way in order that I can actually solder these things. It takes quite a while for the solder to properly reach temperature on these as well, you know, because you've got really thick traces which you need for the current that's provided by a power supply like this. So expect to need a decent soldering iron and desolder station. Mine's set to 480 at the moment. So I'm cleaning up each of these as I go along here and thoroughly inspecting around each one of them. What I would recommend doing is giving the full board a thorough inspection on the solder side, on both sides in fact, before you reassemble it and test it. Just to make sure you've not got a particle of solder somewhere or something joined where it shouldn't be. These black marks here, it's just the foam that has been pressed into the underneath of the thing here, so I'm just going to carefully clean around this with the fiberglass pen. Can't really do it on camera because, as I say, I'm having to hold the board at a weird angle. So the solder points on the bridge rectifier, whilst there's not an actual break, they don't look that clever. So I'm just going to get some fresh solder onto those. Going to go as far as removing the old solder actually. You saw you get little speckles of solder coming out on the board when you use a solder pump like that, so do brush the board down again afterwards. So anyway, you can see that's that one done. Let's do the same on the other points there. So I'm about to reassemble this. You can see the ones with the red dots I've swapped here. The other ones, the ones near the heatsinks, I've took off and measured them, they're fine. Even though this one's the same manufacturer here, it's okay. You tend to find that depending on where they are on the circuit, they can get more stress. Sometimes nearer to the heatsink they get more stress, but not always. It's the same with that one down there, that one's okay. I need to stick a red dot on that one down there because that one has been swapped out as well. And I'm just going to go for broke, reassemble this and retest it, see if it does anything. As I said before, I don't think I showed you, but it just wasn't doing anything at all. We've got all these things loose here, look, but I'm not worried about that just yet. I just want to screw the board back into place. You know, these things are in approximately the right position here. We just need to get the board secured. That's it. Yeah, that was proving very difficult to get in. So that's the board in. I think the next thing I'll do is try and squeeze the fan in. And with things like this, you may need to just bend carefully the metalwork just a little bit, because this is really not designed to allow you to easily remove or replace the fan. You could argue the fan should have gone in first, but this is the way I disassembled it. Try and get it in down there like that, that's it. And as I said a number of times, make sure you use the right screws for the right places. So these fan screws are thick, chunky ones to go into the black plastic frame of the fan. Just dropped a screw into the power supply now. So the next thing I'm going to do is screw the earth in here. That's it, nice and tight. And we'll push the power connector through there. We need to get this switch pushed down and in line with here as well, but I'll screw this in first, I think. So again, the right screws for the right places. I know that these black screws here that are countersunk were the ones that we used to hold the power connector. Your AEC mains connector there. Hope this works after all this. It's been painful to work on. So these things are all sort of cable tied here anyway, but yeah, that just helps us a little bit. So this had a couple of these little twisty things like the fan, you know, quite thick threads. So testing the power supply here, mains lead disconnected, and what I've done here is just bridge the green wire. Now it's not always going to be the green wire, so pay close attention to the way I've got this here and the number of pins and the type of power supply that this is, the model number on the title of this video. It's ATX2 as far as I understand the standard here, but in general you will find that often the green pin is the power on pin, and if you just pull that to ground, and you can see the black wires here all ground, so it's just shorted to ground. So when I plug the or switch on the mains at the socket, this should power on. So I plug it in, switch it on. So it's switched on at the mains, and if I put my hand in front of the fan, I can feel cold air, so that's a good sign. So our meter's on volts DC, and if we measure from one of the grounds, these blacks here, the same one we used for the switch there, to one of the reds, can you see? Got 5 volts there, it's quite stable. And the orange should be 3.3, I think. There you go, 3.34. And over here on the blue, I think we've got minus 12. Let's have a look at that. There you go, minus 11.91, that's fine. Orange should be 3.3 again, I think. So yeah, just go around, measure the voltages, make sure you've got all the voltages you should have on there. Not sure what else we should have. We've got those red ones that are 5, I think. I don't think there's plus 12 on this. Oh, there might be the white one there. Let's just measure that one. So I'll go from one of the grounds there to one of the white ones. Yeah, those white ones may be something else. I don't think those are plus 12 actually. I'll check the pin out in a sec. Let's try the grey one. Yeah, some of these the grey ones are plus 5. One of them is like power supply is good. That's probably what we're looking at there actually. Let's try the purple one. Purple one's 5 volts. Yeah, so on these ATX2 power supplies, I don't think there's a 12 volt line actually. Could be wrong. It's a while since I've looked at a more modern power supply here. Those white ones I'm confused by. Oh, there you go, there's plus 12. Ignore what I'm saying, plus 12 is there, it's on the white ones. I didn't have a good ground before. Yeah, I'm not sure how well you can see that, but yeah, plus 12 is there, it's on one of the white ones on this one. I'll connect an old faulty hard disk up just to see if it spins up. Yeah, trust me to pick a drive that I can't really test it with. What I do know is if I listen to this, I can hear it go as it's trying to start up. So yeah, the power supply is working. I just don't have anything proper to test it with here in terms of a load. So the final things here, got all the screws in, made sure that they're all very tight, especially these 4 here that hold that transformer on the inside. The last thing you would want is it somehow vibrating and these coming loose and the transformer falling off. So do make sure you tighten and then re-tighten all these. Not so much you break the threads on them or snap them off, but they need to be very tight. You can see it's had a bit of an impact there at some point in the past. This is before it got to me. What we might just be able to do with this is just bend these slightly. It's very stiff that actually. Let me just get the pliers. Yeah, just bend a little bit like that. It's not making contact with anything, but it's bugging me. That is really difficult to bend. It must have had a real whack that to have caused that look like that, if I'm honest. Anyway, you can see we've kind of bent that out now. It's almost back in line. That's not too bad. Yeah, there we go. So we kind of bent that out. It wasn't really making a difference to anything, but so this needs to go through the hole. I'm really fiddly to do this, and then I need to use some pliers to grab it from in here, I think, and pull it out like that. and then we can wrap it around the cable and through there like that. It's important you have things like that because that's a strain relief to stop you from pulling it too hard and damaging them where they're soldered onto the board. So just tighten it like that and then just snip it down a little bit. That should do, that's not going anywhere. And exactly the same thing over here, so again I'll have to grab it with the pliers, feed it through. So Simon collected that one and put it in the server and it's working fine. So what I suggest is we'll take the one out that you've just swapped over for, and I'll check that as well because this was the spare, but this has been in use for a number of years in the past as well. The first thing I'll point out, can you see it's a different model completely, and it's got this little clip thing here that goes on and off there, so that's interesting. It's also got, where's it gone now, a little button there, like a reset button or something, and an LED. So this is completely different. I'll show you the model of this one. So I don't think you can see the model there. That's an F305E-00. So it seems to be compatible with the server it's being exchanged with, with that other power supply, but it's slightly different. Well, very different. So let's just have a look inside this to see what state this is in. If the caps look okay, other than cleaning up the fan while I'm there, I probably won't do anything. I just want to just make sure that none of the caps have started to bulge. The one I've fixed is now back in the server and it's been running for a number of days. I'm not sure how this comes apart here. Oh, pain in the bum, this one. Does the bottom come off? Yeah, I think the bottom comes off, look. Yeah, so on power supplies like this where you pull the base off, you have to be extra careful not to get near the board. What's holding it here? I can't see. Nothing, seemingly. Yeah, I'm not liking this one already. I think the other one was better in my mind. At least we can inspect for bad solder joints and things on there. We can get a look inside the power supply here. I mean, you could argue this one's slightly more serviceable than the other one, but in a different kind of way. After you unscrew these two screws here, that connector will come off, which means the board will then come out as well. If you get the screws out of the board there as well, that will come out. You still need to unscrew the power things here and the earth strap and the fan probably. Yeah, you can see the caps in there, look, it's looking fine. I'm not too concerned about that. But the one thing I will do is just carefully lift this up and off. It tucks in at the back here, I have to remember that. And clean this board up. I mean, look at the state of it. Look at that, that's horrendous. That does need a clean. So I'll just measure the voltage of that cap there. Yeah, it's discharged, look. Discharged. So all I'm going to do here is just have a clean with some IPA like this. After having measured the caps on there, I'm comfortable this is safe to do. So I'm not sure what all that dirt is, but you can see it's coming straight off there. No worries. So I've got a little U wire link here, and again, just like we did in the last one, we're going to stick it between the green and one of the blacks next to it. So it's the fourth one. Yeah, an old chopped off resistor or capacitor leg is the best thing to use here. What it should do. And if you keep an eye on the LED here, I've just checked the earth's okay, by the way. See, it's powered on. And on this one again, we'll just measure the voltages. So stick that into one of the grounds there. And these reds I think should be plus 3.3 or something, or plus 5. Not sure whether 3.3 is on this. We've got minus 12 or plus 12 I think over here. Yeah, plus 12 on the white I think it is. What's the orange? Orange is 3.3. Let's check the blue. Blue is minus 12. So yeah, all the voltages are there. I'm sure that power supply is okay. I did say to my boss I was just going to take that apart and have a look. The caps will look fine, and the board is now cleaned up.